Hi friends, welcome to all. In this video we are going to discuss CCNA version 7 packet tracer activity IPv6 neighbor discovery. Before coming to this packet tracer activity, friends, if you are watching our channel first time or if you like to get this type of technical videos in future, consider subscribing. Also don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Also, if you like to contact our technical team or if you like to get more content, you can visit our website. Link I given in the description. Okay, now coming back to our packet tracer activity. Here we can see our addressing table. And here we can see devices RTA, PCA1, PCA2, then PCB1. Coming to our topology, we can see those devices. Okay, in this activity we will do IPv6 neighbor discovery in local network, then IPv6 neighbor discovery in a remote network. In order for a device to communicate with another device, the MAC address of the destination must be known. With IPv6, a process called neighbor discovery using NDP or ND protocol is responsible for determining the destination MAC address. We will gather PDU information in simulation mode to better understand the process. There is no packet tracer scoring for this activity. Now coming to the instructions. In part 1, IPv6 neighbor discovery local network. In part 1 of this activity, we will obtain the MAC address of a destination device on the same network. In step 1, we will check the router for any neighbors that it discovered. Click the RTA router, select the CLI tab and issue the command show IPv6 neighbors from the privileged exit mode. If there are any entries displayed, remove them using the command clear IPv6 neighbors. Coming to our topology, here we can see our router RTA. So we will click on this RTA, then we will select CLI tab. So now we are in CLI tab. We will go to privileged exit mode and we will give show IPv6 neighbors. Enable show IPv6 neighbors. Then we will press enter. Okay, here we cannot see any neighbors, so no need to use this command clear IPv6 neighbors. When you give this command, if you get any neighbors, you can use that clear IPv6 neighbors command to clear those neighbors entries. Next is click PCA1, select the desktop tab and click the command prompt icon. We will close this RTA and coming to PCA1, here we can see that we will click on this PC. Then we will go to desktop tab and here we can see command prompt. Now in step 2, switch to simulation mode to capture events. Click the simulation button in the lower right corner of the packet tracer topology window. So coming to our topology window, here we can see simulation mode. So we will click on this simulation mode. Then click the show all or none button in the lower left part of the simulation panel. Make certain event list filters. Visible events displays none. Okay, here we can see this show all or none. We will click on this. And here we can see event list filters, visible events none. Now from the command prompt on PCA1, issue the command ping space -n space 1 space then this IPv6 address 2001:DB8:ACAD:1:B. This will start the process of pinging PCA2. Okay, better we will copy this command. Then we will go to PCA1. We will paste here and then press enter. Oh, it shows invalid command, because here ping space, here we have to give -n. Okay, 1, then the IPv6 address. We will try this, right? Okay, now click the play capture forward button, which is displayed as an arrow pointing to the right with a vertical bar within the play controls box. The status bar above the play controls should read captured to 150. The exact number may vary. Okay, we will minimize this PCA1 window, and here we can see capture or forward. We will click on it. Okay, we'll close this window, then we will give capture or forward. Even we can see this capture or forward in this event list. We will click on this event list here, and here we can see capture or forward. Okay, we can use either of it. And now here we can see just above this capture or forward, capture to 150.059. Yes. Next, click the edit filters button, select the IPv6 tab at the top and check the boxes for ICMP-v6 and NDP. Click the red X in the upper right of the edit ACL filters window. The captured events should now be listed. You should have approximately 12 entries in the window. Okay, we will do that. Here we can see edit filters. We will click on this button, edit filters, and here we can see IPv6. Then we will search for ICMPv6. It's here. Also we will select NDP. Then we will close this edit ACL filters. Okay, and here we can see in this event list filters, visible events, ICMPv6 NTP, what we selected from this edit filters. And now here we can see all the entries, and it's almost 12 entries. Next is, why are NTPDUs present here? Yes, here if this PCA1 wants to send this ICMP v6 to this PCA2, then he needs the MAC address of that PC. So now this NTPDUs request for these informations in the network. Now click the square in the type column for the first event, which should be ICMP v6. So here in the simulation panel event list, here we can see the first event. The type is ICMP v6. So we will click on this square box. And here we can see PDU information at device PCA1. Okay, now because the message starts with this event, there is only an outbound PDU. So here we can see outbound PDU, that's correct. Under the OSI model tab, what is the message type listed for ICMPv6? We will verify that coming to this PDU information at device. In this layer 3, we can see ICMPv6 echo message type 128. Okay, now notice there is no layer 2 addressing. Click the next layer button to get an explanation about the ND neighbor discovery process. Coming to this PDU information, here we cannot see any MAC address here, but we can see only IPv6 address, source and destination details. So now we will click on this next layer. Yes, here we can see that the next hop IP address is a unicast address. The NT process looks it up in the neighbor table. The next hop IP address is a node in the neighbor table. The NTP process sends a neighbor solicitation for that IP address and buffers this packet. Now click the square next to the next event in the simulation panel. It should be a device PCA1 and the type should be NTP. So here we can see that at device PCA1 itself, and here we can see the type is NDP. So we will close this PDU information and then we will click on this NDP square box. Next is what changed in the layer 3 addressing. So coming to this PDU information, here we can see this destination IP is changed. Now it's FF02 double colon 1 colon double F00 colon B. It's a multicast address. Okay, don't confuse, just we will verify this ICMPv6 PDU information, and here we can see source IP and destination IP. Here we can see destination IP is 2001 colon GB8 colon AC80 colon 1 double colon B. But here coming to this NTP, here we can see it's a multicast address. Next is what layer 2 addresses are shown. That means the MAC address. So here we can see layer 2. Here we can see source MAC address 0001.427e.e8ed. This is the MAC address of our source PC. And here we can see the destination MAC. It shows 3333.FF00.000B. Yes, when a host does not know the MAC address of the destination, a special multicast MAC address is used by IPv6 neighbor discovery as the layer 2 destination address. So we can see this MAC address is a special multicast MAC address. It's 3333.FF00.000B. Next is select the first NDP event at switch A. Is there any difference between the in layers and out layers for layer 2? Coming to our event list, here we can see a device, and here is switch A, and we will click on this NTP, and here we can see PDU information. Here we can see in layers and out layers, layer 2 there is no change. A switch is not going to change any information. Okay, now select the first NDP event at PCA2. Click the outbound PDU details. What addresses are displayed for the following? The addresses in the field may be wrapped. Adjust the size of the PDU window to make address information easier to read. So we have to check this address: Ethernet 2 destination address, Ethernet 2 source address, IPv6 source IP, IPv6 destination IP. Okay. We will verify that. We will close this PDU information at this device switch A. Then we will search for this PCA2 NTP at device PCA2. Okay. Then we will click on this square box. And here we can see PDU information. Okay, now here we can see out layers. We will go to outbound PDU details tab. Then we will check for this Ethernet 2 destination address. Here we can see Ethernet 2, and here is the destination address. It's 0001.427e.e8ed. Okay, then Ethernet 2 source address. Here we can see that 0040.0bd2.243e. Then IPv6 source IP, it's here 2001 colon db8 colon AC80 colon 1 double colon B. Then IPv6 destination IP, it's here 2001 colon db8 colon AC80 colon 1 double colon A. Okay, now select the first NTP event at RTA. Why are there no outliers? We will close this PDU information, and then we will search for RTA. Here we can see that. We will click on this NTP square box. Here we cannot see any outliers because the IPv6 address does not match the router's address, so it drops the packet. Now click through the next layer button until the end, and read steps 4 through 7 for further explanation. So coming to our PDU information, here we can see next layer. We will click on it. We'll click once more, and here we can see the description. Now we will read these steps from 4 through 7. The packet is an NTP packet. The device processes the packet. The NT packet is a neighbor solicitation. The neighbor solicitation's target IPv6 address does not match the receiving port's IPv6 address, so this NTP process drops the packet. Yes, so the NTP process drops the packet, and we cannot see any outliers here. Next is click the next ICMPv6 event at PCA1. We will close this PDU information at device RTA. Then coming to our simulation panel, here we can see PCA1 and ICMPv6. We'll click on it. Next is, does PCA1 now have all of the necessary information to communicate with PCA2? So we will verify that from this PDU information at device PCA1. So here in this outliers we can see source IP address, or okay, and here we can see destination IP address. Okay, right. And coming to layer 2, here we can see Ethernet 2 header. Here we can see a source MAC address, and here we can see destination MAC address. Yes, so now PCA1 have all of the necessary information to communicate with our PCA2. Next is click the last ICMPv6 event at PCA1. Notice this is the last communication listed. And what is the ICMPv6 echo message type? We will close this PDU information at device PCA1. Coming to our simulation panel, here we can see the last event at device PCA1. It's ICMPv6. We will click on this star box. Here in this PDU information, here we can see ICMPv6 echo message type is 129. So this 129 is a received an echo replay message. So it's an echo replay. Next is click the reset simulation button in the simulation panel. From the command prompt of PCA1, repeat ping to PCA2. Hint, you should be able to press the up arrow to bring the previous command back. Okay, we will do that. We will close this PDU information. And here we can see a reset simulation button. We will click on it. Okay, now we will go to this PCA1, and here we will press up arrow so that we will get the previous command. Then we will press enter. Okay. Then click the capture forward button 5 times to complete the ping process. Okay, we can do that. Just we will close this simulation panel. Then here we can click capture or forward. We can see it goes to a switch A, then PCA2, then back to PCA1. Right, so again we will click on this event list. Now in this simulation panel event list, we can see only ICMPv6 type. We cannot see any NTP events. Why weren't there any NTP events? Yeah, obviously because PCA1 already knows the MAC address of PCA2. So it does not need to use a neighbor discovery. Now we will move to part 2, IPv6 neighbor discovery remote network. In part 2 of this activity, we will perform steps that are similar to those in part 1. Except in this case, the destination host is on another LAN. Observe how the neighbor discovery process differs from the process you observed in part 1. Pay close attention to some of the additional addressing steps that take place when a device communicates with a device that is on a different network. Yes, we can do that. IPv6 neighbor discovery on a remote network. Before that, make sure to click the reset simulation button to clear out the previous events. Okay, here we will click on a reset simulation in the simulation panel. Coming to step 1, capture events for a remote communication. Display and clear any entries in the IPv6 neighbor device tables as was done in part 1. Yes, we can do that. We will go to our router RTA, then a CLI. Okay, here we will give enable and we will give show IPv6 neighbors. So here we cannot see any neighbors. Okay, otherwise we have to give this command clear IPv6 neighbors. Now switch to simulation mode. Okay, here what we will do, we will go to real time, then we will go to RTA and we will check for the neighbors, show IPv6 neighbors, and here we cannot see any neighbors. Okay, now we will go to simulation mode. Click the show all none button in the lower left part of the simulation panel. Make certain the event list filters visible events displays none. So here we will click on this show all or none. Currently we can see in event list filters visible events ICMPv6 and NTP. So we will click on this show all none and here we can see now visible events none. Now from the command prompt on PC A1, issue the command ping. We'll copy this command. Okay, to ping host PCB1. Okay, just we will close this simulation panel and we are going to ping from this PC A1 to this PCB1. Okay, we will go to PC A1. Already we are in command prompt. Okay, here we will paste that command we copied. It's a ping space -n space 1, then the IPv6 address, then we will press enter. Now click the play capture forward button, which is displayed as an arrow pointing to the right with a vertical bar within the play controls box. The status bar above the play controls should read capture to 150. The exact number may vary. Coming to our simulation panel, here we can see that capture forward button. We will click on it. And here we can see capture to 150.172. Now click the Edit Filters button, select the IPv6 tab at the top and check the boxes for ICMPv6 and NTP. Click the red X in the upper right of the Edit ACL Filters window. All of the previous events should now be listed. You should notice there are considerably more entries listed this time. Yes, we are going to do the same step what we done in part 1. So here we are going to click on edit filters. Then in IPv6 we are going to select ICMPv6 and NTP. Then we will close this window. And here we can see many events. Now click the square in type column for the first event, which should be ICMPv6 because the message starts with this event. There is only an outbound PDU. Notice that it is missing the layer 2 information as it did in the previous scenario. Coming to our simulation panel event list, here we can see the first event at device PC A1, it's ICMPv6. We will click on this square box and here we can see PDU information at device PC A1. Yes, as they specified here in this video information, we cannot see in layers, so we can see only out layers. And here we can see this layer 2 is missing here. I mean, this information is missing here. Now click the first NTP event at device PCA1. So we will close this video information because it's ICMPv6. Then we will check for PCA1 NTP. Here we can see that PCA1 NTP. We will click on it. Okay, right. So what address is being used for the source IP in the inbound PDU? Actually, not in the inbound PDU, it's in the outbound PDU. Okay, here we can see that the source IP address FE80 double colon 201 colon 42FF colon FE7E colon E8ED. Actually, it's a link local address for PCA1. Yes, IPv6 neighbor discovery will determine the next destination to forward the ICMPv6 message. Next is click the second ICMPv6 event for PCA1. PCA1 now has enough information to create an ICMPv6 echo request. Now we will close this PDU information and we will search for the next ICMP v6 event for PCA1. Here we can see that. We will click on it. Now, what MAC address is being used for the destination MAC? So coming to our PDU information at device PCA1. Here we can see in this layer 2 Ethernet 2 header. Here we can see a destination MAC address 0001.961d.6301. So this MAC address belongs to our router RTA interface gigabit Ethernet 0/0/0. Now click the next ICMPv6 event at device RTA. Notice that the outbound PDU from RTA lacks the destination layer 2 address. This means that RTA once again has to perform a neighbor discovery for the interface that has the 2001 TB8 SE80 2 double network, because it doesn't know the MAC addresses of the devices on the G0/0/1 LAN. We will close this PDU information at device PCA1. Then we will search for the RTA device. RTA ICMPv6. I will click on it. And here we can see this layer 2 informations are missing. Skip down to the first ICMPv6 event for a device PCB1. Okay, we will search for this PCB1 ICMPv6. PCB1, but it's NDP. Okay. Here we can see PCB1. We will click on this square box. And here in these outlayers we can see layer 2 informations are missing. Here, what is missing in the outbound layer 2 information? Obviously the destination MAC address must be determined for the IPv6 destination address. Now the next few NTP events are associating the remaining IPv6 addresses to MAC addresses. The previous NTP events associated MAC addresses with the link local addresses. We will close this PDU information, and here we can see NTPs. Now skip to the last set of ICMPv6 events and notice that all of the addresses have been learned. The required information is now known. So PCB1 can send echo reply messages to PCA1. Coming to our simulation panel, here we can see those ICMPv6 events. And here we can see the details. Ethernet to header. Okay, coming to switch A and PC A1. Right. Now click the reset simulation button in the simulation panel. From the command prompt of PC A1, repeat the command to ping PCB1. Okay, we will reset this simulation. Then again we will go to PC A1 command prompt. We will use the up arrow. Then we will press enter. Now click the capture forward button 9 times to complete the ping process. So whether any NTP events, so we will verify that. Just we will close this simulation panel so that we can view it. We'll click on capture or forward. Okay, we clicked this capture forward button 9 times and this ping completed. So we will click on this event list, and here we can see only ICMPv6 type. We cannot see any NTP events. Now click the only PCB1 event in the new list. What does the destination MAC address correspond to? Now coming to our simulation panel event list, we will click on this PCB1 event ICMPv6. And here we can see the MAC address. Destination MAC address 0001.961d.6302. The MAC address of our router interface gigabit Ethernet 0/0/1. The MAC address of this interface G0/0/1. Next is, why is PCB1 using the router interface MAC address to make its ICMP PDUs? Obviously, because the destination device is on another network. PCB1 addresses the PDU to the default gateway interface MAC. RTA will determine how to address the PDU at layer 2 to send it towards its destination. Okay, now we will go to step 2, examine router outputs. Return to real-time mode. Okay, we'll click on this real-time. Click RTA and select the CLI tab. At the router prompt, enter the command show IPv6 neighbors. Coming to our router RTA, CLI. Here we are going to give show IPv6 neighbors. We can press up arrow so that we will get the previous commands we used. And here we can see the details. Here we can see in this result it shows 1, 2, 3 and 4 IPv6 address. Okay, how many addresses are listed? So it shows here 4 addresses. We can see IPv6 global unicast address and link local addresses. Also we can see it shows the MAC address for PCA1 and PCB1. Okay, what devices are these addresses associated with? Yes, already we told it's PCA1 and PCB1. Next is, are there any entries for PCA2 listed? Why or why not? So it's not listed because PCA2 has not communicated across the network. Okay, now ping PCA2 from the router. Okay, we can do that. Here we will get the IPv6 address for a device PCA2. We will copy this address. Coming to the router, we'll ping to that IPv6 address. Okay, so we have to type that address here, 2001 colon db8 colon ac80 colon 1 double colon b. So success rate is 100%. Now issue the show IPv6 neighbors command again. Are there entries for PC82? It should be there. We will check that. We will give show IPv6 neighbors and then press enter. And here we can see the details. Yes, here we can see IPv6 address and MAC address for this PCA2. Here we can see that, and it's a MAC address. Okay, we will close this RTA, and here we have some reflection questions. When does a device require the IPv6 neighbor discovery process? Obviously, when the destination MAC address is not unknown, this process is similar to our ARP with IPv4. Next is, how does a router help to minimize the amount of IPv6 neighbor discovery traffic on a network? Yes, usually the router keeps neighbor tables so that it does not need to initiate neighbor discovery for every destination host. Next is, how does IPv6 minimize the impact of the ND process on network host? It uses a multicast address so that only a handful of addresses would be listening to the neighbor discovery messages. IPv6 creates a specially crafted multicast destination MAC address, which includes a portion of the node address. Finally, how does the neighbor discovery process differ when a destination host is on the same LAN and when it is on a remote LAN? Yeah, when a destination host is on the same LAN segment, only the device that matches the IPv6 address responds and other devices drop the packets. When the device is remote, the gateway device, usually a router, provides the MAC address of the interface on the local interface for the destination MAC and then searches for the MAC address on the remote network. The router will then place the corresponding IPv6 MAC address pair in the IPv6 neighbor table. So it's similar to our ARP table in IPv4. Okay, so that's all in this packet tracer activity, IPv6 neighbor discovery. Now friends, if you have any doubt, any suggestions, please comment below. Also, if you like to contact our team, you can visit our website, a link already given in the description. So stay tuned and we will meet again with the next video. Thank you.